Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah, wassalatu wassalamu ala rasulillah. Alright, so welcome to our final class of the semester. Alright, inshallah, before you go to final exam on 8th of August, inshallah. Alright, so as I mentioned, we only have one more topic to cover. So in the last class, we already covered on the layout for product layout. All right, based on the material handling cost. All right. So in this week, inshallah, we'll go to the next one, which is on process layout. All right. So how to design the layout for the process layout. All right. Right. So I just before I forget about the final exam. So before this, I told you that we will cover all the LOs. All right. So we basically in this course we have 5 LOs. Right. I think if I remember correctly. So if I make some mistake, you can correct me. So we have PLC, pneumatics, CNC, layout, and SCADA. All right. So we have 5 LOs. So in we have finalized our final exam draft. So it will only be consisting of 4 LOs. All right. So it will be in the mixture of PLC, pneumatics, and of course the combination of both. And then on CNC as well as the layout. All right. So product and process layout, inshallah. Right. So the SCADA one I just put in your recent quiz. Okay. So that's all for the SCADA and IoT. Right. So you won't have SCADA and IoT in the final exam. That's the thing I want to highlight. All right. Okay. So let's continue with our class. So I think we have already finished this one, right? For the design of product layout using line balancing. Okay. So still remember all the heuristics. So you need to, revisit all those heuristics and choose the best for your layout. Right. So in this class, we'll focus on the process layouts. Okay. Okay. Still remember the difference between product and process layout. Right. So process layouts, remember, is we want to design the position of the department. All right. So departmental position where we want to put each of those based on each function, as well as based on the minimizing the material handling costs. All right. So the designing process layout equals to designing the layout that can minimize the material handling costs. So we don't want to have lots of material movement between departments. All right. As we want to give the best layout based on the minimize material handling. All right. So process layout features some departments benefit from adjacent locations. Right. Of course, if you have similar functions between departments, so you need to make them closer to each other. All right. Otherwise, if it is far from each other, we need to impose some material handling costs. Okay. Okay. Some departments must be kept separate. Okay. External factors such as the location of entrances, windows, elevators, and so on. All right. Flow costs for material and personnel within the building are critical. All right. So the flow cost not only for the material handling, but also the personal flow. All right. So the movement of the people between department, that one is also in some cost. You know. All right. Okay. These are the steps for the process layout. So basically, we have some 6 steps. All right. First of all, you need to construct a from-to matrix. Right. From-to matrix meaning that from one department to another department, all right, showing the flow of parts or materials from department to department. Okay. Step number 2, determine the space requirements for each department. All right, the dimension of the department. So it can be, easy ones will be having the same dimension. All right, so maybe a square room with same dimension, right? So it can be in other dimensions as well. Okay, so this one need to be put into your consideration as well. So step number 3, develop an initial schematic diagram showing the sequence of departments. Right. So based on this from to base and the dimension, you start with your initial diagram. Okay, you start with your initial diagram. This one you just put whatever layout that you want to propose. After that, you determine the cost of that layout. Okay, all right. How to calculate the cost? All right, simply the total of x into e. So what is x and what is c? Right. So x basically is the number of move between department. All right, and then C is the cost of the movement. Okay, so for each of the between department value, you need to total up all of those to get the cost. All right, and then those with the lowest cost you take as your layout. Okay, so you want to minimize the cost. Okay, all right, and then after you calculate the cost of your this diagram, initial schematic diagram, so you try to improve, you make new iteration so that the cost can be further minimized. Okay, all right, by trial and error or by use of a computer program. Prepare a detailed plan considering space or size requirements. So the constraint not only the space but also the requirements, right? So maybe because of the size, because of the functions, right? Maybe because of some other factors as well. All right. So maybe someone want to be in that room, right? So you cannot move him from that room. So you can only move other rooms, to make the new layout. Okay. So there's some requirements that you need to take into consideration as well. Okay, so this basically the steps to calculate, to design the process layout. So we'll see this in more detail in the next example, inshallah. Okay. For that, there's some coming in. Okay. All right. Let's say we have this type of from to matrix. Okay, from to matrix. So this one is a example of a toy company. So you want to design the process layout for this manufacturing line. Okay, so let's say you have 8 departments. You have shaping, molding, metal sewing, right? Toy assembly, large toy assembly, painting, assembly. All right. So you have 8 departments, and you want to arrange them in this layout. All right. So basically, all of these departments have the same dimension, 40 by 40. All right, and you want to put them in a large plan consisting of 80 times 160. All right, so basically you will have 2 times 4 matrix. Okay. Okay. Yeah. All right. So this one, you can see that this is the from to matrix, right? Denoting the flows between the departments. Okay, so this one is just the value of how many times the material flows from department to department. So this one meaning that from 1 to 2, right? From shipping to plastic molding, there is 175 movement, some sort of that, right? So you can see that the one with the highest movement is this one, which is from 6 to 7, right? 6 to 7, right? 374, right? Between large toy assembly and painting, for example. Okay, and then you can see also there are no movement at all between departments. So from 1 to 4, shipping and sewing, so maybe they are not related to each other, so there is no movement between those. Okay, so these are the the movement between departments that is represented by from to matrix. Okay, and then you have the layout here that you want to redesign. Okay, let's say for the second step, you choose the initial design, right? So let's say this one is your initial design, so you can put in any order, up to you. Okay, up to you. So let's say we put this one in sequence 1 2 3 4 and so on up to 8. All right, and then step number 3, you calculate the you put you determine the flow first. Okay, so this one you can see from the from to matrix before, right? So from 1 to 2 175, from 1 to 3 25. Okay, from 1 to 6 200, right? Of course you also have this 7 and 8 here that is not shown. Okay, all right. And then what you need to do is you calculate the cost. Okay, so how to calculate the cost? Easy. So for those in the adjacent, so the one which is nearby to each other, for example 1 and 3, you multiply the cost to 1. Okay, all right. Because it is near to each other, so you don't incur any costs. All right, so for those with that you need to skip a department, so for example 1 to 5, you need to put the cost as okay. So and then same from 1 6, so also you need to skip like one department here. So this one also you times by 2. So now instead of 200, you need to 400. That times 200. So you can see here, you can see the multiplication here. Okay, like this. Okay, so this one before this is 30, right? So if you want to more, I think I just copy this one, compare. Okay. Okay, so this one is your two matrix just now. So this one is based on the initial diagram that you propose. So you can see that 1 to 2, no cost at all. So because it is adjacent to each other, as well as 1 to 3. So same 25, 25. And then you can see that the one that is highlighted in red, you need to incur some cost. All right. So if it is, if you need to skip one department, you times by 2. So 1 to 5 and 1 to 6, right? This one with 2, as well as 2 to 5 and 6, right? To 1, all right? So this one you also multiply by 2, and then you know that you 8, 7 and 8. So as for that one, just skip 2 department, right? If one department skips 2 department to go to the the destination, you need to give the cost as the multiplication of 2, of 3, sorry, of 3. Right. So for example, 1 to 7 here, so you need to skip 3 and 5. So you need to multiply by 3. So 1 to 7, this one, right? To 20 multiplied by 3, you get 60. Okay. And then the same to this one, 1 to 8, right? So you need to skip 2 departments. Okay. Although it is a diagonal move, but it is also 2 departments. So you need to multiply by 3. Okay. So okay. The same for other as well, right? This one, in this example, you only have 2 rows. So maybe if you have more than 2 rows, then you need to make sure to give the cost accordingly. Okay. This one. Okay. So we delete again. Right. So you just calculate those. Okay. And then you total up. Okay. You take this with the new cost, and then you total up all of this 175 plus 35 plus 60 plus 400 and so on up to 7. Okay, and then you get the total cost, right? So this total cost implies that this is the cost that you need to pay, if you stick with this layout. Okay. All right. So now what you need to do, you need to make a new iteration so that you can minimize the cost further. Right. So how to do that? Right. So now you rearrange the layout. So how based on what? So let's say this one is the revised layout, exchange 1 and 4. Why we choose 1 and 4? Because you see in this from to matrix before, sorry. Okay, in this from to matrix, you can see that you can actually choose based on the movement that have the more the high cost. So for example, 1 and 6 here you have 200. Okay, so you may want to close to each other, right? So instead, this one you need to incur times 2. So if you move 1 to 6 in the nearby, so you can just multiply by 1. Okay. Right, so you want to bring 1 and 6 next to each other, and this is one way to do it. All right. So maybe you want to put here or here. So this one, of course, based on the flow, the material flow between department. All right. So maybe you start with this one, and then you need to recalculate the cost. Okay, the cost. So here I give you the cost first. All right. So this one is the updated one based on this layout, right? So for example, 1 to 6 now you don't need to multiply by 2 because now it is close to each other. So 200, maintain 200, and then 1 to 7. So instead of times 3, now is time 2, right? 1 to 7 and 1 to 8. Right, so 1 to 7 from 20 times 2, you get 40, right? 1 to 8 from 25, you get 50, okay? And so on. Of course, 2 and 8 and 2 and 7 still have the same cost, all right? So this one you can actually minimize them, right? Okay, so what's the total cost you have now? So you total all of this one, you get something like this. Okay, so you can recalculate by yourself. So this one maybe not very correct. You can make correct calculation after this. Okay, so let's say you have something like this. So and compare with the previous one, which is okay, which is 3449. Now you get 3234. Okay, 3234. So this one is looks like the cost is lowered, right? Decreased a little bit. Okay, that's actually our reason for the layout. Okay, so can we further reduce the cost? All right, so of course, because you can see that which one incur lots of cost, and it is they are far from each other, right? So maybe 2 and 8, for example. Yeah, 2 and 8, now 270, which is quite high. Okay, this one 270, and 2 and 7 also very high, 240. So maybe you want to move this one to somewhere here, okay, or here, right? So if you swap 2 and 6, so 1 and 6 still adjacent to each other. So but now you can actually, if 2 is here, you can actually lower down this cost between 2 7 and 2 and 8. Okay, all right, so you can go for more iterations. Okay, and then these are this is the best final feasible solution after several iterations. So you can see that the arrangement quite different from the initial one that you proposed just now, right? Okay, so now you can see that uh, 2 and 8 now is very near. Okay, 1 to 6. Okay, so of course this one need more iteration to see the to minimize the cost. All right, so normally for this type of layout, we want to to target for some reduction cost, right? So let's say we say that we want to reduce up to maybe 20% of the initial design, right? Right. So maybe based on the existing layout, you want to rearrange so that you can minimize up to 20%. Okay, so that the type of problem that you may face in the future. Okay. All right. Any problem? Any questions? Okay. So the process layout example. Okay, how to design the process layout. So this one is not very difficult. So you just need to keep track on the cost. Just multiply with the material movement. Okay. So this one, you can see now you are given the cost in terms of this movement, right? So maybe in other problems you have other requirements as well. Okay, so we'll see after this, inshallah. Okay, so okay, so not only this one based on the requirements of the material movement, so you can put other requirements as well. So for example, you want to have this closeness rating. Okay, instead of the distance between department, you may want to give some rating to the closeness. So this one absolutely necessary, for example, right? A, absolutely necessary. Credit department and camera department need to be close to each other, right? So especially important, ordinary closeness, okay. You unnecessary, right? So you can have this type of rating to give to show that this one need to be close to each other or not, okay. Right, and then you can give some based on the rating, reason rating as well, right? Reason for rating. So let's say you have 6 code, 1 to 6, right? So you give rating of 1 for the flow of materials, okay? Like this one, right? And you give code of 2, ease of supervision, convenience, okay? And so on, right? So maybe for the based on the safety reasons, this one cannot move, and so on, right? Of course, this one just just a additional knowledge for you, right? So you can have something like this, okay? And then not necessarily you have the same dimension, right? So in the last example, you have 40 by 40, right? So right now you may have different dimension, okay? So let's say you have 50 by 20, right? So you can have lots of layout to propose, okay? Based on the requirement. All right, so this one is another examples. Okay, so you go through by yourself. Okay, so this one is the dimension of the department. Okay, you already be given, and then this one is your from to matrix. Okay, so you need to calculate the cost and try to minimize the total cost of material handling. All right, you may have something like this. So for example, eight work centers must be arranged in an L shape. All right. The location of centers A and E are designated as shown in the accompanying diagram, like this one. Okay. So A and E here now you cannot be moved, right? So maybe due to safety reasons, or maybe this one need to be here so that the truck can load easily or something, okay. All right, assuming transportation costs are $2 per load per meter, develop a suitable layout that minimize transportation costs using the information below. So this one is same like we have before. So this is the distance, this one the loads per day. So this one you can this can represent the cost of the metal movement. So this one maybe metal movement, or number of flows, for example, number of flows of material. All right, so how many movement per day between each department. Okay. So this one can be represented by many things that can represent the cost. Okay. Maybe the cost of the movement per se. All right. So cost of material handling. Right. So maybe this one in term of the dollars. Okay. And so on. Okay. So right now, if you have something like this, you need to multiply with this distance, right, from two matrix. Okay. Right. So that's all for the process layout. All right. So you have product layout, you have the process layout, and then you also have this so-called group technology. All right. So this one some sort of combination between the product and process layouts, because you know that in one big manufacturing you can have combination of the mixture of product and process layout. So this one parts having similarities in geometry, manufacturing process, and functions manufactured in one location. Right. So similar things with similar process, all right, with similar technology, you group them together, right? So that's why it is called group technology, right? Group technology is based on a general principle that many problems are similar, all right? So this is the keyword. And by grouping similar problems, a single solution can be found to a set of problems, thus saving time and effort, right? So this one just for the additional knowledge. All right. So let's say you have something like this in the existing plant, right? So you have this lathe machine, milling department, drilling, and then you have the grinding and assembly. Okay. So you know that some of the process, it can be from lathe directly to milling, right? So this one, of course, good flow. Okay, good flow, like very good, very smooth, right? So you know you want to minimize this uh, you know redundancy of the movement. All right, so you can actually do something like this. Okay, so lathe milling, right, so in one department, all right, in one cell, right? So this one can have the very smooth flow instead of before you can have this redundancy. Okay, right? So of course this redundancy will incur lots of costs, okay, and time consuming. So if you have something like this, okay, so the flow of material can be smooth. Okay, so that's group technology. Hybrid layouts. Okay, this one's similar to group technology as well. So this one you can see from the raw material up to the assembly, you have multiple processes. Okay, you can see that is I have lots of redundancy, so you can group them together to have something. We call it as part routing matrix. So let's say part A to make the part A, you need to use machine 1, 2, 4, 8, and 10. All right. And then for B, you need to use machine 5, 7, 11, and 12. Right. So you can actually rearrange this one, product flow analysis, which is you want to reorder part routing matrix to identify families of parts with similar processing requirements. So from this one, I think you can already see that some of the parts have similar or near similar uh, machines, all right, process. So for example, A here, 1, 2, 4, 8, 9 is same, with the D. Okay, so you may want to group them together. Okay, so as well as this one is also similar, right? Maybe you can group them together. Okay, as well as C and C, which uses 3, 6, and 9, and this one G, right? Similar, right? Of course, it has another one, 12. Okay, so you can group them together like this one. Okay, and then you can have the very smooth flow without, you can minimize the redundancy of the material movement, right? So this one A, D, and F. Okay. Right. So group technology, the advantages. So this one you go by yourself. All right. This one is I think the ultimate one that we want to have, right? So you want to reduce the cost of the material handling. Okay. Work cell advantages. So this one you go by yourself, right? So of course you have some limitations as well for this type of layout, as well as the process and product layout. Okay. All right. So you know that you have the process, product, hybrid, or the group technology, and you have also this fixed position layout. So this one, of course, for the one that involve very big project, for example, for the ship assembly, for example, so it is in a fixed position. So instead of you have you need to design the layout of your process or product, so you need to bring all of the machines and process to the location here. Okay. Okay, design is for stationary projects, right? Workers and equipment come to site, all right? So limited space at site, changing material needs. Okay. Right, so this one you go through yourself, right? So this one is if you make some comparison based on the volume and variety. Okay, these are the mapping. Okay, process layout have a very flexible in terms of variety of product that it can perform. All right, but product layout you can see that it is much more conventional. The product variety is low, right? So this one maybe more for the mass production. Okay, and you can see that why mass production, because it is more suitable for the high volume of production, and of course you cannot make lots of different design. Okay. Okay, so fixed location is here, cryptology here. So this is the mapping of the layouts. Okay, so this safety issue. Okay, so safety is the most important one. When you go to your work, right? So that's why we call it safety first, right? Safety first. So this one normally people tend to forget about this safety precaution. All right. So because accident must be avoided at all costs. Okay. So even if you have near miss incident, near miss. Have you heard of this one, near miss uh, incident? So you can Google this one. So near miss basically, sometimes when you operate the machine, okay, or the worker operate the machine, sometimes you nearly caught your hand, for example, right? So the accident nearly occur. Okay, so this one you need to, if this one happen, you need to report directly to your boss or supervisor. So this one, if you go to Japanese manufacturing plant, this one is a very important one. So this one need to be reported straight away, and swift action need to be taken instantly. Okay, all right. So this one safety. So this one you go by yourself. All right. So because safety issue is a very important one, because even in our kuliah, we have seen different type of accident happen in our labs, right? So if you still remember, I think in 2 or 3 semesters ago, someone caught his hand from the cutting machine. All right. So of course, the fingers gone, right? So this type of things you need to be very, very careful. So of course, safety is the absolute first thing that you need to consider, right? So you need this SOP and first aid. So especially in this time of COVID, right? So you need give the safety as your highest priority. All right, so this one log out and tag out. So this one you go by yourself. Okay, so if the you have faulty machines, you need to make the log out and tag out. Okay, so this one you go by yourself. Okay, so that's the end of our class today, inshallah. So I think I open for questions first today. Do you have any questions? Of course, after this, you still can ask me on my WhatsApp. Okay. All right. So Muhammad Izzat, so I have question. Oh, sorry. I have question regarding quiz. Yeah, please ask now. Which question do you want to ask? In question 3, all right. Do you have a microphone so you can speak easily? Or if you don't have microphone, you can write. No worries. Okay, in question 3, the G code is given, okay? Cannot create circle. Yes, okay. This one is purposely done. Okay, so this one you need to propose how to make the correction. Okay. Okay, so let's say you expect a circle at the end of the path, so you can make the correction to the code. Okay, all right. Any other questions? I think I have a question from you guys before. From who? This one. So for tomorrow class, we need some explanation about last question in the quiz. What is the last question? Okay, before that, can you repeat what come in for the final? So for final, all will be us except SCADA and IoT, right? So SCADA IoT, you will find only in your final quiz, okay? That I call it quiz come assignment, okay? So there are 4 questions. So one for PLC, one for pneumatics. So this one will give you video, video that you need to watch, and then you need to propose the solution for that system in the video. And then the third one is what? CNC. CNC. This one similar to your quiz. Very easy. And then layout, all right? Product and process layout. So basically, you for the calculation, you only have 2, right? product and process layout. So expect those to come in the final. Okay. All right. So this one, last question in the quiz. Someone asked about that one. Oh, this one. This one. Last question in the quiz. Oh, this one. So SCADA and IoT allow distributed input to be continuously monitored without the intervention of an operator. Oh, this one. So this one you need to make you know some summary of the SCADA and IoT. So this one I suggest that for your for your easy work, easy job. So I think you need to find a company. You choose one company, and then you summarize whatever the SCADA and IoT system use in the company. Right. So this one can be in terms of the general requirement of the SCADA. Right. So maybe the requirement is this IoT system need to cover 1 acre of plant, for example. So the general requirement, it can be anything, right? So and then the network architecture, right? So what is the network architecture of the SCADA and IoT? Does it need the Profibus or the internet or the the Ethernet? So what type of network? Okay, so interfaces, security protocol. All right, what type of sensors that the company use? Actuators. So maybe you take company. I think last 3 semester we went to, of course this semester you don't have to visit, right? So last 3 semester I think we went to, what you call it, Shabas. Shabas. So of course Shabas have the different sensors and actuators. If you compare with for example TNB, right, Tenaga Nasional Berhad. Okay, right? So and then some in the state of the art, you can see that PLC people use that one with Arduino, right? So instead of you can code in using ladder diagram, you can also code using Arduino Studio. Okay, it has the interface that can combine those, right? So controller, and the latest one, it has AR VR for the monitoring. All right. So for example, you want to see if this machine is faulty. So if from the AR VR, you can it can give alarm to the the one this to the supervisor, right? So and then where the data is kept. So this one is historian, cloud server, web server, right? So what type of cloud server? All right, so maybe use AWS, for example, for the IoT. So you need to give the examples. All right, so this one maybe you can give the technical papers, websites, or the YouTube, anything. All right, so this one much more open-ended. Okay, so let's say I think can I give you example? Maybe this one. So for example, you you see something like this. Okay, one research paper on laboratory SCADA systems, state of the art. So maybe you want to summarize this paper, right? So up to you. But the thing is, you need to give the reference, whatever reference that you refer. You can copy and paste. You can rephrase, up to you. But I need those information, and please put the reference. Please cite the reference from where you take. All right, the materials from. Okay. All right. So, any other questions before we end our class today, inshallah? Okay. So, if there is no question, I think we end this class and this semester. Okay. All right. So we end this class with tasbih kafara and surah wal-asr. Subhanakallahumma bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Bismillahirrahmanirrahim. Wal 'asr innal insana lafi khusr illa alladziina amanu. Okay. Assalamualaikum warahmatullahi wabarakatuh.